So during the last class, we covered the Pythagorean theorem, which allows you to find the missing side if you know two other sides of a right triangle. Today we're going to talk about right triangle trigonometry, specifically SOHCAHTOA, and how we can use that to find a missing side, knowing one angle and one other side. So firstly, we're going to want to memorize this expression. It says SOHCAHTOA. What it means is SOH stands for the sine, which is a button on your calculator, of a given angle will be equal to the measure of the opposite side of that angle, meaning the side across from it, over the hypotenuse. The hypotenuse is its own side. Secondly is the CAH, which is the cosine of a particular angle, which is going to be equal to the side that is adjacent to that particular angle over the hypotenuse. Now, the hypotenuse will often appear to be the adjacent, but it cannot be both. It can only be the hypotenuse, and if it's not the hypotenuse, it's the adjacent. The last one is TOA, which stands for tangent, which is also a button on your calculator. So the tangent of a given angle is equal to the measure of the opposite side of that angle over the adjacent side to that angle. So let's take a look at this right triangle that's drawn here. We have a right triangle here with two unknown side measurements. We know that it is a right triangle, so we know this angle measures 90 degrees and has a 30-degree angle, and we're being asked to find the measure of angle x. So the way we're going to do that is we're going to take the side that we do know, which is 3, the side we don't know and want to know, which is x, and the angle that we have in this problem, and we're going to use it with the trig ratio to solve for the missing side. So what we're going to do is we are going to write a trig ratio using these two sides. Now, angle A in this case is here, meaning that x is the opposite side, and y is the hypotenuse. Now, we're not using the hypotenuse in this problem because we aren't being asked for it yet. The other side is the adjacent side, meaning it is next to the angle in question. So because we're using the 30-degree angle, and we're going to be using the side measuring 3 and the side measuring x, that's the opposite and the adjacent. And if we look at SOHCAHTOA, the trig ratio that uses opposite and adjacent is tangent. So what we're going to write is that the tangent of the angle, which is 30 degrees, is equal to the proportion of the opposite side, which is x, over the proportion of the adjacent side, which is 3. And now in order to solve for x, we're just going to put tan 30 over 1 and cross multiply. We'll get 3 times tangent of 30 is equal to x. Now we can calculate this using our calculator. So we're just going to do that really quickly. I'm going to open the calculator app on my iPad here. I'm going to go into mode and make sure we're in degree mode because we're working in degrees, not radians. We press second mode to go back to the main screen. I'm just going to type 3 tangent of 30. If we do that, we get x is equal to 3. That doesn't seem accurate to me. Is that accurate? I guess it could be. We'll get x is equal to 1.73205. Let me write down the entire decimal. Most likely the problem you're working with will tell you to round to some specific number. Oh, that's more than enough. So that is the measure of angle of side x with the tangent. All right, so now we're going to take a look at a similar triangle. So if we look at this triangle, A prime, B prime, C prime, it's actually a similar triangle to the other triangle. We can tell because they're similar by AA. We're going to find angle x in that triangle as well. Now, if you look at the corresponding sides, AC and A prime, C prime, you'll notice that one has been doubled to get to the other. So we can already predict in advance that our answer should be 2 times what we just measured. So we should get 3.46. All right, so let's try and set up our trig ratio here as well. So we're going to be using the tangent of 30 again. This time it's going to be equal to x over 6. Because this is still the opposite side, and this is still the adjacent side. And we're just going to cross multiply again. We're going to get 6 tangent of 30 is equal to x. And we're just going to use our calculator. So 6 tangent of 30 is going to be equal to 3.46. So exactly as I said, it doubled. So if you think about that, that makes sense. So if this is 3.46, it'll be the same thing if this was 1.7. They'll have the same fraction. You can also find it using the other angle. It doesn't matter which angle you use. If this angle was 30, then by the triangle sum theorem, the other angle would have had to have been 60. So let's say we wanted to use the 60-degree angle instead. So we're going to be using angle B. Now from angle B, 3 is now going to be the opposite side, not the adjacent side. And we're still going to be using x, which is the adjacent side. So despite that in the previous example, I labeled the other one adjacent and opposite, I'm using a different angle, so it has a different label. Opposite and adjacent are still part of tangent, so we'll use tangent again. So the tangent of 60 degrees should be equal to 3 over x. In this case, I'm going to use a little shortcut to help me solve for x. If you cross multiply, it doesn't matter which things are on which part of the cross, so I'm just going to switch the x with the tangent of x. It's going to be an equivalent equation, and I'll get x over 1 is equal to 3 over tangent of 60. So now I just have to write 3 over tangent of 60 in my calculator, and I'll get the value of x. All right, so we're going to write 3 divided by, 3 divided by tangent of 60. And we get 1.73. which is the same exact answer we got when we did this using tangent of 30. We just had to lay out our fractions differently. Now let's say I wanted to find the hypotenuse using the 30-degree angle. Well, in this case, this is the adjacent side, and this is the hypotenuse. So now that means we have to use the part of SOHCAHTOA that has A and H in it. So we're going to write it down again. SOHCAHTOA. So A and H are part of cosine. So we're going to write the cosine of our angle, which is 30, is going to be equal to the adjacent, which is 3, over y. And we're going to solve for y. We're going to put this over 1 and switch the cosine 30 with y. So we get y over 1 equals 3 over cosine 30. And we're going to get y is equal to 3 divided by cosine 30. Press enter. Whoops. We get 3.464. So that's the measure of y, and it's a reasonable number to get because it has to be bigger than the other two sides because the hypotenuse is the longest side in the right triangle. Excuse me. We're going to calculate it using the 60-degree angle as well. So from the 60-degree angle, this would be the opposite side, and this would be the hypotenuse. So this one's going to actually use sine because it uses opposite and hypotenuse. So the sine of 60 will be equal to the opposite, which is 3 over x, the hypotenuse. We'll put this over 1, and we'll switch the sine of 60 with x. So x over 1 equals 3 sine of 60. So we get x is equal to, using our calculator, we should get the same answer we did a moment ago, 3 divided by sine of 60. We get 3.464 once again. And that's pretty much all we needed to discuss, although I will show you one more thing, actually. I'm going to draw a right triangle here. I'm going to label this side 3, 4, and 5. We'll call this A, B, and C, C being the right angle. This is a standard right triangle. 3 squared plus 4 squared does equal 5 squared. If I pick angle A, then this side is the opposite, and this is the adjacent, and this is the hypotenuse. And we can just write down all three trig ratios that go with angle A. So the sine of A is going to be equal to 4 over 5. The cosine of A is going to be equal to 3 over 5. And the tangent of A is going to be equal to 4 over 3. If we were to find the trig ratios from B, this side would be the opposite, and this would be the adjacent. This one is still the hypotenuse. So we're going to write the trig ratios for this. The sine of B is going to be equal to 3 over 5. which an interesting thing is the sine of b will be equal to the cosine of a. These are called cofunctions. That's actually why one is sine and one is cosine. They have the exact same value from different angles. The sine of b will be equal to the adjacent, which is 4 over 5. So the sine of b will match, I'm sorry, I wrote the sine when I meant cosine. So the cosine of b will be equal to 4 over 5, which will be the same as the sine of a. And the last one would be the tangent of b, which will be 3 over 4, which is the opposite of the tangent of a, because the opposite and the adjacent have switched based on the angle we are using. All right.